to moderators and all the audience. So my name is Tong Hao Ken. My title is about a review on the numerical study on heat transfer performance enhancement of phase change material, or PCM, by nanoparticles. So this is my presentation outline, which include introduction, reviews, and conclusion. So the background of my study. So what actually is phase change material? Actually, phase change material are ideal product for thermal management solution. This is because the phase change material can store and release thermal energy during the process of melting and freezing. So the diagram shows a simple freezing and melting cycle of the phase change material. First, initially the PCM is in solid state. As the environmental temperature rises, the phase change material will start to absorb the heat from the surrounding, and it will start to melt. After that, the solid PCM will slowly become a liquid state. So at this moment, actually a cooling effect is occurs since the heat absorbed by the phase change material and the surrounding air will become cold. So in another hand, when the environmental temperature has dropped, the liquid PCM will release the heat energy back to the surrounding, and the solidification of the phase change material will occur until it's become a total solid again. Actually, this is a cycle. So next, this is a phase transition diagram of during the melting and the freezing process. On both diagrams, we can see that the horizontal line is the moment where the phase transition is occurred. So we will see that when during the phase change, there are lots of latent heat can be stored or released. And here you can see that during the phase transitions, actually the temperature does not change much. So we can conclude that with almost a constant or little difference in temperature of melting and or freezing point, abundance of latent heat can be harvested. So basically, there are four types of phase change material, which include the phase transition between solid-solid, solid-liquid, solid gas, or gas-liquid. But normally, the most common used PCM are the solid-liquid type, which can be further categorized into organics, inorganics, and euthetics. Euthetics PCM are a combination or mixing of two or more organics and inorganics material to form a new substance. So next, I will give some advantages and disadvantages of the organics and inorganics phase change material. Organics phase change material are non-corrosive, low or non-subcooling, chemically and thermal stability. However, they are facing lower phase change enthalpy and lower thermal conductivity. However, the inorganic phase change material posting the great phase change enthalpy, but they are suffering from the subcooling, corrosive, phase segregation, and the lack of thermal stability. So actually, phase change material are widely used in thermal energy storage, heating, ventilation, and many applications. But now I will more focus on the application of phase change material in thermal energy storage. Actually, thermal energy storage are additionally installed to assist the cooling system to perform its work. It consists of the PCM capsule inside it to help it function as a latent heat storage. So the thermal energy storage is helpful because they're balancing the supply and the demand of the energy. Hence, it can conserve the energy consumed by cooling. So why the PCM is in the thermal energy storage is important is because from the pie chart, you can see that most of the energy consumption used in Malaysia, either in home or office, are actually consumed for the cooling purpose. And the table shows that since 2013, every year the electricity price keep increasing, so it may lead to high living costs. So it's important to find a solution to conserve this energy, and the high performance of PCM in the thermal energy storage can solve this problem. So actually the purpose of the PCM is to work as a latent heat storage to melting and freezing. However, the problem is the PCM are unable to work at high efficiency due to poor thermal conductivity. This is because subcooling occurs and inefficient in transfer heat. So one of the suggestions is to enhance the performance of the phase change material by introduce or adding the nanoparticle inside it. So what is nanoparticle? Nanoparticles can be considered as a metal outside of a carbon tube with a nanoscale that contains higher thermal conductivity. These are the example of the image of the nanoparticles. So a nano-enhanced phase change material can be formed by dispersion of nanoparticles into it through two common methods, which is one-step method or two-step method. The one-step method involves the simultaneously fabrication and the dispersing the nanoparticles into the base PCM, while the two-step methods are usually the powder of the nanoparticle are generated first, and the dispersion of the nanoparticle will be at the subsequent step. So this is the example of the two-step method. So next I will go through the review. For my review, I found that the Konadi and Hospodani were probably the earliest researcher that performs the investigation on enhancing the phase change material through the dispersion of nanoparticles, which occurred in year 2007. He was inspired by the report of the Medusa in 1993 because their learning on the improvement of the thermal conductivity after dispersed ultrafine particles into the liquid. So by using copper nanoparticles and water as PCM, they studied the freezing of the nano-enhanced PCM within a differential heated square cavity that started with steady state nature convection. From the investigation, they found that as the volume fraction of the nanoparticle increased, the solidification time is shortened for a fixed threshold number. After that, many researchers have been inspired to do a similar study. So there are some common findings that are found by those research, which is, and I'm doing a summary on it. Most of the researchers found that the addition and dispersion of the nanoparticles into the base phase change material can enhance its thermal conductivity and melting and freezing rate. And less energy are required to complete the melting and freezing cycles. Higher volume fraction of nanoparticles when dispersed into the pure PCM, it will give a greater enhancement effect. But if excess nanoparticle are added into the PCM, it will degrade the heat transfer rate. And last but not least, they have also found that there are little degradation in the latent heat. However, there are also some findings that disagree with the enhancement of the PCM by the adding of nanoparticles. Haslim and his group found that when they are using copper oxide as a nanoparticles and cyclohexane as a PCM, by using scanner analysis, the results show that the maximum stream function value decreases when the nanoparticles are added to the base PCM. The decrease in the steam function values is an indication of the reduction of the liquid PCM motion when the nanoparticles are added. So the location of the melting point also shows that the melting of the PCM is prolonged when the nanoparticles is added. But this is only a few researchers come out with this conclusion. But there are also one interesting finding that I found is instead of adding only one type of nanoparticles, the ICASEA and his group has adding two or more type of nanoparticles into the base PCM to enhance it. Those particles involve copper nanoparticles, aluminium, silicon oxide, and the titanium oxide. So they found that in a single nanoparticle system, which means adding only one type of nanoparticles, the silicon oxide gives the best performance. For adding two types of the nanoparticles, the combination of 6% of silicon oxide and 6% of aluminium is more effective. And compared to the single system, which means adding two types of nanoparticles is better than adding one type of nanoparticles. Nevertheless, the best performance is obtained by adding the combination of three types of nanoparticle, which is the 6% of aluminium, 3% of silicon oxide, and 3% of titanium oxide into a PCM. So this research has actually opened a gap for the future researcher to do and try to enhance more the phase change material by adding more than one type of nanoparticle. So I also, from the review, I also found that most of the numerical study on the heat transfer performance during freezing and melting process are based on the enthalpy porosity method. So there are some assumptions that we make for the study, which is the flow of the liquid PCM is considered as an incompressible, unsteady laminar, while the liquid PCM behaves like a continuous medium with thermodynamic equilibrium. And there are no slip velocity between the base PCM and the nanoparticles, and the thermophysical properties of the PCM are assumed to be constant. Where the density and in the buoyancy force terms is solved using the Poisson approximation. So, in a conclusion, it can be said that nanoparticles can be concluded as a promising additive for PCM in order to enhance its heat transfer performance. However, there are still lack of study on the effect of adding more than one type of nanoparticles into the PCM. It is also lack of the correlation to determine the optimum condition of the parameter that affect the enhancement in the heat transfer performance of PCM. So further research and development are required to solve those challenges. These are the references I studied. And thank you.
Thank you, Mr. Do. Questions to